Welcome to this video on database scaling. In this video, I'll cover some of the basics and motivation behind database scaling, as well as discuss some of the important database scaling techniques. Let's start with the motivation. Suppose you have a database server that is starting to get increasingly popular with multiple users. So individual users will submit requests, either through a front end or directly to the database server. Now, as the number of requests increase, you may hit the limitation of the database software or hardware. And after a certain point, your performance will start to dip considerably. So there is a point at which a database server will hit a performance bottleneck. Now, consider the other case where you have a database server and you have a bunch of clients that are constantly providing updates or inserting new data into the database server. As you can imagine, over time, you will experience a capacity bottleneck because the database server simply doesn't have the space to store all of the information that it's receiving from clients. So let's look at some of the scaling techniques. The simplest scaling technique that we can first cover is vertical scaling. Now, in vertical scaling, you simply take your database server that you were using to run your favorite database program and storing all of your information, and you sort of move that to a much bigger database server. By bigger, I mean, you have improved hardware or software, and you typically increase the size and specifications of the CPU, memory, disk, or network. Now, this approach has a few strengths because the migration is quite simple. You simply use the existing software and data, but you just move it to a new server. However, it has a few limitations. The first thing is, as you go to the higher end of the hardware, like as you start buying the fastest CPU, the most amount of memory, the fastest and most and best disks with the most capacity, or high-end network hardware, which has very high bandwidth and low latency, this starts to get very, very expensive. More expensive than, say, buying 2 small database servers or 2 medium database servers. So that's one limitation. The second limitation is you're limited to the most powerful hardware available. So your scalability is basically determined by what is the biggest and most expensive and most powerful server you can buy today. And for several, applications which have millions of clients, like, internet services and web services companies, you simply cannot handle all of the requests using a single server. So you have to think of beyond vertical scaling in that sense. So let's look at the other form of database scaling, which is horizontal scaling. In horizontal scaling, you take a database server and you scale it to multiple database servers in a database cluster. Now, the question here is, well, this makes sense in theory, but practically, how do you scale? How do you manage the data? How do you ensure what part of data goes to what server? And how do you sort of orchestrate this entire thing? So there are 2 basic ways in which you can do horizontal scaling. The first idea is of replication. Now, replication is quite simple, and the technique is right there in the title. A database server is simply replicated to multiple database servers in a database cluster. So the same data that is there on one database server is replicated to multiple servers. Now, let's take a look at replication in action. Now, you can have multiple clients contacting individual database servers in the cluster, and they can make read requests without any issue. And in fact, all of these requests can be serviced in parallel. So what happens when you have write requests and you have a replicated database cluster, right, with servers that all have the same data? Now, if a client makes a write request to a single server, that data must be copied to all of the other servers. Otherwise, the data might be inconsistent. And we'll cover consistency later in a later video, and it's a fairly large and complicated topic, but this should just give you an idea of sort of the limitation of replication. You have to think of ways in which you can keep data consistent across all of the replicas when clients are writing data. But otherwise, if your database is mainly oriented towards read requests, replication is a fair solution to do scaling. Let's look at the other option when it comes to scaling. This is known as sharding. In sharding, you take a database server, and what you do is you split up the data that is in the database server and you distribute it to the individual servers in your database cluster. So the data gets partitioned between individual database servers in the cluster. Now, let's take a look at various types of sharding. So in the first example, you have a database cluster which has 2 or more servers. And I'm taking a single table that is stored in the database server and I'm splitting that table based on the rows. So some of the rows will go to server 1 and some of the rows will go to server 2. Now this sharding technique is known as horizontal partitioning because you're taking a table and splitting up the rows in the table based on some criteria, and you're distributing that across servers in your database cluster. The other technique in sharding is to take a table and, as you may guess, you're going to split the columns of the table and provide the columns to individual servers in the database cluster. Now, this is known as vertical partitioning. So these are the 2 basic forms of sharding that can be used in database scaling. One in which you simply split up the rows of a table and assign them to different servers, and the other in which you split up the columns and assign them to different servers. Now, depending on the type of application, one approach or the other, or maybe a mixture of these approaches, might be most suited, and this will depend on your schema, the type of typical queries that you encounter, and a whole number of other factors that can determine what is the appropriate database scaling technique for a given database that is filled with some kind of data. All right, so to recap some of the concepts in this video, we talked about database scaling. And we talked about 2 types of scaling. The first is vertical scaling, in which you simply take a database server and you give it more improved, higher performance hardware. So you scale up the CPU, RAM, and disk, but you don't touch the database as such. You just simply migrate it to better hardware, and that is known as vertical scaling. And in horizontal scaling, you take a single database and you split it up into multiple databases, giving it multiple servers. And horizontal scaling has 2 main types that we talked about. First is replication, where you have the same data that is replicated across multiple servers, copied across multiple servers. And as you remember from my discussion just a few slides back, replication is really good for databases that mainly service read requests, because write requests are difficult to keep consistent across replicas. And the other approach is sharding, in which you break up the database, the actual data in the database, and assign it to multiple servers. This can be done in many ways, one of which is vertical partitioning, in which you simply split up the columns of the database and assign them to individual servers. And then you have horizontal partitioning, where you simply split up the rows of an individual table and assign rows to individual database servers in your database cluster.